This video was produced by students for training purposes only and is provided on an as-is basis. ISU and the state of Idaho make no warranties about the completeness, reliability, usefulness, or accuracy of this information. Any action you take upon the information provided is strictly at your own risk, and ISU and the state of Idaho will not be liable for any errors, omissions, losses, or damages in connection with the use of the contents of this video. This video demonstrates how to stitch UAS images together in Agisoft Photoscan to produce a digital surface model and orthorectified image of a lava flow. After opening Agisoft, add photos by clicking Workflow and Add Photos. Navigate to a folder that contains all of the photos that you want to include in the model. Select all photos by holding down Ctrl and pressing A, and click Open. After photos are added, use low alignment to match overlapping portions of the images and create a preliminary sparse cloud. Click Workflow and Align, choose the low setting, and click OK. To reduce error in the model, we will create and place markers on the images. Right-click on a recognizable feature in an image and click Create Marker and note the marker number. In this case, it is marker 5. Now navigate to another image that has the same feature and either move the predicted marker location to the correct location or right-click on the feature and select Place Marker, then choose the correct marker number. Cycle through all of the photos to make sure that the marker is correctly placed on any image that contains it. If we know the distance between two markers, we can use this to create a measured scale. Highlight the 2 points with a known distance in your Reference tab. Right-click the selection and click Create Scale Bar. A new scale bar will show up in the scale bar window. Click once on the blank area below distance and then type the known distance in meters. Now perform a high alignment to produce an improved sparse cloud. Click on Workflow and Align Photos. Choose the high setting and click OK. Now gradually select erroneous points in the sparse cloud to improve the accuracy. Click Edit and then Gradual Selection. And select Reconstruction Uncertainty. Adjust the bar below to change the number of points that will be selected. Click OK and then press Delete on the keyboard to remove these points. Click Edit and then Gradual Selection. Select Reprojection Error and adjust the bar below to change the number of points that will be selected. Click OK and then press Delete on the keyboard to remove these points. Click Edit and Gradual Selection again and then select Projection Accuracy. Adjust the bar below to change the number of points that will be selected. Click OK and then press Delete on the keyboard to remove those points. Repeat this process until the number of projections is near 100. Now that the sparse point cloud quality is improved, build the dense point cloud. Click Workflow, then select Build Dense Cloud. Make sure the quality is set to high and the depth build is set to aggressive. Press OK. Build a mesh that's based off your dense point cloud by clicking Workflow and selecting Build Mesh. Change the surface type to height field. Change the surface data to dense cloud. Change the face count to high. Expand the advanced settings and disable interpolation. Click OK to build the mesh. The final piece of the model is to build the texture. Click Workflow and select Build Texture. Set mapping mode to orthophoto. Expand the advanced settings and make sure color correction and hole filling are unchecked. And click OK. Now build the DEM. Click Workflow and select Build DEM. Make sure that the source data is set to dense cloud and click OK. Now build the orthophoto. Click Workflow and select Build Orthomosaic. Set the surface to DEM and click OK. Export the DEM in the Reference tab. Right-click on the DEM and click Export DEM. Select Export TIFF Bill XYZ. In the next screen, click Export. Give the file a name and click Save. Export the orthomosaic back in the Reference tab. Right-click Orthomosaic and click Export Orthomosaic. Select Export TIFF Bill XYZ. In the next screen, click Export. Give the file a name and click Save. The next video in the set will demonstrate lava terrain analyses that can be performed using the digital surface model.